with the ADC that we have to generate some known voltage. You know, if we have internally in our DAC, we have an unknown voltage. We have a known voltage, and we have a comparator that's looking at the two, trying to decide when the known voltage transitions past the unknown voltage. We developed this little stair step where we had some known voltage that was doing this over time. All right, so this was our known voltage. And our unknown voltage maybe was right here. And so when the known voltage passed the unknown voltage, there was a change on the comparator in the A to D converter, and we knew we'd discovered our unknown voltage. So the way this, we didn't talk about this last time, but the way this known voltage is generated is by use of a DAC. So DAC is a digital to analog converter. And a really simple DAC would be to take a 4-bit counter. And the output of that 4-bit counter is going to have a 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0 weighted output. And if we put those through resistors that have similar weightings, say 1K, 2K, 4K, and 8K, and then these guys are summed up in a kind of a and they go into an op amp. You could sum the currents when these outputs go on. So if you have a 0001 here, and this current here is, or we have 3.3 volts, and it's going through this 1K resistor, and we have a virtual ground in this op amp, then we could calculate the current using Ohm's law. And that would give us 3.3 milliamps into this op amp. But if we used a value like that, where we have 1000, we would have 3.3 volts divided by 8K, 412 microamps. The weights might need to be flipped. So the lowest resistor is giving us the highest current, so we probably need to flip these. So if you have two of these on, your currents are going to add up. And they're going to add up with binary weighting. And so as the counter counts, what's going to happen is you'll generate, on the output of this guy, you'll generate this stair step. Now, the good thing is we don't have to do all this. We don't have to deal with this because the DAC chip that we're using has this all built into it. And it probably actually uses not these type of resistors, but it uses a ladder that's called an R2R ladder. That you get the same effect by using resistors that have very similar values, and they would they would put the resistors in like this. And then it would go into the op amp. And in the R2R ladder, you would have a value of R and 2R, R and 2R. Or maybe 2R and R. I'm not sure which one's which. But ultimately,